Good, good morning to all. Today we are going to discuss our unit 3 flood and drugs. So under the topic of flood estimation. So the flood estimation course outcome assess the flood and drugs risk in terms of hazards and vulnerability and analysis the measure for mitigating and managing such risk. So the course outcome is analysis based. So from this topic we are going to estimate the flood. So the course outcome 3 correlated program outcome 2, 3, 6, 7 and then program specific outcome 1. So the flood estimation, flood control, physical indication of past flood, flood marks and a local inquiry, rational method, unit hydrograph method, empirical method, flood frequency methods. So empirical method for flood estimation, the Deacon formula Q is equal to C into M, the whole power 3 by 4, where C is equal to 11.4 for North India, C is equal to 13.9 to 19.5 for Central India, whereas the Western India C is equal to 22.5 to 25. Depend upon the climatical condition, it will be differ the values of C, where the reverse formula Q is equal to Cm power 2 divided by 3, where C is equal to varies from 6.8 to 15 kilometers. C is equal to 6.75 if area is less than 24 kilometers from coastal area, where C is equal to 8.45 if area is 24 to 16 kilometer, where C is equal to 10.1 for hill area, Q is equal to discharge in kilometers, M is equal to area in square kilometers, where Halley Navjing Jung Bagros formula, that is 0.9932 divided by 14 log A, where Q is equal to CA, value of C taken from 48 to 60. This is applicable mainly in Deccan's plains, where A is equal to area of catchment in square kilometers, where Ingles formula Q is equal to 123 into A divided by SQRT into A plus 10.4, where A is equal to area in square kilometer. So the English gave the following formula derived from data collected from 37 catchments in Bombay Presidency. So the Coles formula R is equal to P minus T in minus 32 divided by 3.75, where T is equal to mean temperature F, R and P are in centimeters, where for Ghat area R is equal to 0.85 P minus 30.5, where R is runoff in centimeters, P is equal to precipitation in centimeter. For non-Jhat area R is equal to P minus 17.8 into P divided by 254, where Barlows and Legacy have also given empirical formula as under R is equal to K into P, where R is runoff, P is equal to precipitation, K is equal to runoff coefficient for different class of catchment like A is equal to flat cultivated soil, B is equal to flat far tail cultivated, C is equal to average, D is equal to hills and plain with cultivation, E is equal to very hill areas. The Barlow has added another coefficient based on light rain, average rainfall with intermittent rains and continuous downpour, etc. So the legacy has given a formula as R is equal to P divided by 1 plus 304.8 F divided by PS, where S equal to catchment factor, S is equal to catchment factor, F is equal to reservoir duration factor, which is based on different classes as defined by Barlow's equations. So see the Barlow's table, class based A, B, C, D, E, the nature of season, a light rain, maybe no heavy downpour, average or no continuous rain, then continuous downpour. Then description of catchment, flat, cultivated and black cotton soil, flat party cultivated stiff soil, average catchment, hills and plain with little cultivation, very high and steep with little or no cultivation. So from here the runoff percentage based the A calculation, the 10, 15, 20, 35, 45, A, B, C, D, E, the light rain and average rain and continuous downpour. Likewise, the values are maintained. The rational method, in this method, the basic equation which correlated the runoff and rainfall is as follows: Q is equal to C into I into A, where Q is equal to runoff in cubic meter per hours, C is equal to runoff coefficient, I is equal to intensity of rainfall in meters per hours, A is equal to area of the drainage basin square kilometers. Intensity of rainfall meter per hours in I is equal to P divided by TR. into Tr plus 1 divided by Tc plus 1, where P is equal to precipitation in meter, Tr is nothing but storm period in hours, Tc is nothing but time of concentration in hours. If Tc is not known, then I is equal to P divided by Tc. That means time of concentration Te in the time in hours taken by rainwater that falls at the furthest point to reach the outlet of a catchment. So the value of runoff coefficient C depends on the characteristics of the drainage basin such as soil type, vegetation, geological features, etc. For different types of drainage basins, the values of C are given below in table. Table value of C for different types of drainage basins. Type of drainage basin, value of C, where rocky and impermeable 0.8 to 1.0, slightly permeable in bar 0.6 to 0.8, cultivated are covered with vegetation 0.4 to 0.6, cultivated absorbed soil 0.3 to 0.4, sandy soil 0.2 to 0.3, heavy forest is equal to 0.1 to 0.2. So see the unit hydrograph method, the date based, hour based, discharge in commercial base, and RDNs and ordinate. So the come flow direction unit iteration, the 12 August, 13 August, 14 August, based on the curve it will be increased, again it will be decreased. So graph based number of hours with the discharge in cumulus. The maximum flood with the different formula, the MFD, area velocity method, come divided by second, Q is equal to A into V into HFL. That is, we got this much of values from here. Then MFD at this site can come by second, this value, Ingel's formula. Then MFD rainfall intensity method, C into I into A. Rational method come divided by second, 124.385. Then MFD at this site, GOG standard project flood method comes on second, that is 223.21. Average MFLD is equal to 22.22. So these are the reference material. Thank you.